Welcome to our mini lesson on waves. Most of us are familiar with ocean waves, water that tumbles over itself and crashes against the sandy beach. But we experience waves all the time. Sound waves, light waves, and even electromagnetic waves, which include microwaves, radio waves, and X-rays. But what really is a wave, anyway? A wave is a disturbance which transfers energy through a medium, or in other words, it's a movement through air, water, land, or space. Waves can move in a few different ways, but we're going to focus right now on longitudinal waves and transverse waves using our slinky. In the longitudinal wave, the slinky is moving in the same direction that the wave is traveling. In the video, you can see how the coils of the slinky come together and move apart as energy or disturbance passes. In a transverse wave, the slinky is moving back and forth at right angles to the movement of the wave. You can see it moving up and down. Waves are described by their movement, but we can also measure them by their wavelength and amplitude. Wavelength is the distance between each wave, generally measured from the top of one wave to the top of the next, or conversely, the bottom or trough of the waves, as the yellow bar here indicates. The distance between the waves can determine what we see, hear, or experience. For example, in the rainbow, each color has its own wavelength. Shorter or closer together wavelengths are the violets and blues. Longer or farther apart wavelengths are oranges and reds. The amplitude is the height of the wave from the normal resting location. The height can determine how loud a sound can be, for example. In our video, we can see how the waves are generated by dropping a stick in the water. That is the disturbance. Each ripple is a wave, and the distance between each ripple is the wavelength. But what happens when the wavelength or amplitude change? Changing the wavelength can change the colors we see in a rainbow, or changing the sound wavelengths or frequency can change the sounds we hear. Longer wavelengths are lower sounds, while shorter are higher, as you can see in the first graphic. Changing the amplitude is basically the volume control, as you can see in the second graphic at the bottom. Larger amplitudes are louder, and smaller are quieter. Let's watch this video that shows how the scientist is changing the wavelengths with the larger dial and the amplitude with the smaller dial, and we can see how the sound is different and seen on the oscilloscope. Note that as the waves get closer together, the sound gets higher. And the volume changes with a change in amplitude. Smaller wavelengths, higher sound. Have you ever had music played so loud that you felt the beat of the bass? Sound wave can actually move things. Let's take a look at how this tuning fork is impacting the sugar. The vibration or sound waves from the tuning fork causes the sugar to jump around in the petri dish. This picture is also made from waves, but not sound waves, but seismic waves. Seismic waves are waves that travel through the earth causing earthquakes. Earthquakes are caused by the movement of the plates on the Earth's crust. When they shift, the motion we feel is called an earthquake. Earthquakes are measured by the different types of wave reaching a seismograph. P&S waves are carried deep in the earth, but the more damaging surface waves move the land we build our houses and communities on, as you can see in this picture. This picture was from the earthquake in San Francisco in 2019. But waves are everywhere. They're all around us by using the internet, our phones, and televisions, to the sounds we hear and the light we see, even cooking our food. Explore what types and where waves are found around you. Thanks for watching, and see you next time.